within statistics, we are going to be talking about a few concepts, some that you've done in grade 7, some that are going to be brand new. But overall, in the Foundations 20 curriculum, we're going to be hitting 2 different outcomes. Now, they're very closely related. The 20.6 outcome is going to be a lot greater on the depth. For example, we're going to be talking about normal distribution, standard deviation, z-scores, as well as tying back to our grade 7 understandings. And 20.7 talks about some interpretation of data, which involve confidence intervals, confidence levels, and margins of error. A nice outcome rubric, which allows you to have an understanding of 6, meaning that you can explain the application, meaning, and purpose of standard deviation, properties of normal curve, and the z-score, and you can solve different situational questions. And to understand your confidence intervals is being able to critique real-life examples in which that data is used to support a particular position, and you can support that position by analyzing the data to consider other factors. In section 1, we're going to talk about a few different things. So first thing is we're going to talk about range. Now the range is strictly your maximum value subtracting your minimum value, aka your dispersion. So if your minimum value is 9 and your largest value is 100, oh, that's definitely wrong. You'd just be taking 100 and subtracting 9. Wow, I just love triangles. Okay, 100 subtract 9 is 91. Wow. There we go. So our mean is also known as the average. So to find out your average, you just add your numbers together, determine how many numbers, and you take your total number, so what you calculate in one, and divide it by the total number in the data set. That's a small typo, that should just be a point. The symbol for mean is an X, a cursive X with a line over top. It just means your mean, your average. And you've been calculating that since grade 7 at least. You've actually been calculating all 3 of these things since grade 7. And I'll talk about exactly what those are just as soon as I finish talking about median. So median is the middle value of an ordered data set. So as long as you put your data in order from least to greatest, or in some kind of rough approximation, there's different ways of doing it. If there's an odd number of data, you just have to find out what the middle number is. If there's an even number of data, though, you find the mean you just have to find the mean of the middle 2 numbers. So if you have an even number, say it's 29, if you have 29 values, then your 15th data would be your median. Whereas if you have 4 data values, the mean between your second and third ordered data is your median. The mode is the number that appears the most often in data. And you can have more than one. So what that means is if you see a number that occurs more than other numbers, you could potentially have 2 or 3 different modes. Of course, if every single data value occurs the exact same amount of time, you would have no mode. Special term for mean, median, mode is they are called the measures of central tendency. The reason that they are called the measures of central tendency is because most data seems to centralize around the mean, median, and mode. Not every single bit of data, but overall, your middle kind of set of data, so your average, your median, your mode, they all will kind of be in the middle of your data set. Not always, but very commonly. Next definition is an outlier. So an outlier is a value in a data set that is very different from other values. So if you have the number 1 and then all of your other numbers are in between 100 and 110, the number 1 would for sure be an outlier. It's something that's very different than all of your others. And a stem and leaf plot is a chart which helps to organize a range of data values into type formations so you can analyze. So we're going to do actually an example of a stem and leaf plot in our first example. Example 1, you're buying a new car battery and 2 brands at the same price. This is the data of how long the car batteries last in years of 30 different batteries that people have bought of each brand. So we have 5.1 years, 5.2 years, 5.8, 7.0 years. The first thing that we're going to do is we're going to create a stem and leaf plot. Now, the idea behind a stem and leaf plot is it's just going to help us organize this data. The method that we use to create a stem and leaf plot is we have to look at what our data is. The biggest thing is our data has a whole value and a decimal value. So the best way to help itemize this, the stem would be whatever the whole number is. The leaf would be the decimal part of that number. So 5.1, we're going to go 3, 4, 5, 6, 7, 8. 5.1 would put us there. 7.3 would be there. 6.9, 4.7, and 5.0. And we'll fill in the rest of the table. So after brand X is filled in, our chart would look like this. We have 3.3, a 3.1, and that's identified right there and there. For brand Y, it's going to be the same kind of thing. Now, a stem and leaf plot does not have to be a whole number with a decimal. It could be dealing with tens, or it could be dealing with even hundreds. Your stem could be your 100, and your leaf would be the part of that. So similar fashion, 5.4, 6.3, 4.8, 5.9, 5.5. So all of those values will get plugged into our chart. And therefore brand Y would look like this. Question B says we're going to find the measures of central tendency, our range, and identify any outliers to help compare the data. So our first thing that we're going to find out is we're going to find out our mean, our average. And the quick way that I like to show my work that I'm still going to be doing my average correctly is I have 3.3, a 3.1, 4.7, 4.8, 4.1, 4.3, 4.6, and it's all going to go up to an 8.1 and 8.2. So the way that I show my work that I'm still going to add up all my numbers and divide by the 30, because there's 30 batteries. Sorry, I should probably identify that this is going to be brand X. And we'll do brand Y over here. This is me showing that I've done all my addition. When I add it all up, we get a total sum of 172.3. So 172.3 divided by 30. Is approximately 5.74. Now you don't have to go off your stem and leaf plot to do your average. It's just another method, just like the stem and leaf plot. Stem and leaf plot is one way to help us organize. You can go straight by hand. You could find out what your smallest number is and start with 3.1. And then you have to go through everything else and find 3.3. And then the next one would have to be a 4.1. Then your 4.3. 4.6. But a stem and leaf plot is just one way that you can help organize the data. Just like if I wanted to find out my median, if I have 30 car batteries, and by definition, the median, there's an even number of data, we're going to have to find the mean of the middle two numbers. So to split 30 in half, we'd have to find out what is the 15th and what is the 16th number. Well, the great thing is on a stem and leaf plot, we kind of can organize it just as it is. We know that there's 2 here, there's 5 there, which means that that's 7 values. So if I find out that there's going to be how many more? 4, 5, 6, 7, 8, 9, 10. Well, if there's 10 data values in here, that does mean that we have 17 values all the way up to here. So this would be the 17th, 5.8 would be the 16th, and a 5.7 would be the 15th. So to calculate what our median is, you'd just have to take the 5.7, add the 5.8, and divide it by 2. That's a nice quick calculation of 5.75. The mode is a last measure of central tendency, and it's the number that occurs the most. Again, a stem and leaf plot is another great way to help identify. See, we only have one 3.3, one 3.1. We only have one 8.1 and one 8.2. I don't see any repetition of decimal values. Yes, I do. Okay, there's 2 6.4s. There's 2 5.0s. But I can read that there's 1, 2, 3 5.7s. So 5.7 would be our mode. Range, really easily calculated as well. Because if we have our stem and leaf plot, we can quickly identify what the values are. Our highest value would be an 8.2 and our lowest value is a 3.1. So 8.2 subtracting that 3.1 is 5.1. And are there any outliers? Overall, our outliers, we see a huge congregation in between the 5 and 6. Now 4.7 and 4.8, 4.6, not too far off. These values probably wouldn't even be considered to be too far off either. But this 8.1, 8.2, and even these 3 points would probably be considered as outliers, because they're just too far off of the rest of the data. The next closest number here will be a 4.1, which is about 0.8 of a year. Closest number here is 0.6 of a year between the 8.1. So it's just because it's too far away from the rest of the values. The rest of them, if we were to plot them, with 3.1, we have a 3.3, and we have 4.1. These values that are just on the outside of it would just be too much. It's too far out. So we have multiple outliers. We have 3.1, 3.3, 8.1, and 8.2. For brand Y, we're going to do the same calculations. We're going to find out what our average is. We're going to find out what the mean is. Now there are no 3s, but I can take my 4.8, 4.7, 4.5, 4.9, 4.9, add all my 5 points, all my 6, all the way to my 7.0. So again, a quick way to still show that you're doing your work. 4.8, 4.7, and I'm adding it all the way to the 7.0. Right, it was 4.8 and 4.7? Yeah. Now I could have just as easily taken all my values for brand X or brand Y straight from the table, but it's just however you feel most comfortable. I could have started with 5.4, 6.3, all the way to the 5.6, 5.9. Could have done that too. I could have gone vertically and got 5.54, 47 to the 5.85. It doesn't really matter how you do it. Just show your work. Show that you can do grade 7 work. So we add up all those values. We will get a sum of 171.7, which divided by that 30 is approximately 5.72. Our median can be calculated very similarly. I'm just going to write down the next few things that we're going to be identifying. Median. So again, we want to find out the 15th and 16th numbers. And what would they be? So in no discernible order, we have the first 5 numbers here. Well, there's another 5, and there's another 5. So we're already at 15 and 16 being in here. So we're going to have to put things in order. We would have to do at least a 5.0, 5.1, which would give us the 6th and 7th numbers. 0, 5.1. So the next number will be 5.3. We have 2 5.4s. Now I know that some people can do this ordering in their head. I'm just showing another method. See another 5.5. See 1 5.6. 2 5.7s. 2 5.8s. And 3 5.9s. Now just to confirm, make sure that I actually have all those numbers down. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers just in the 5s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I missed a number. So I'm going to have to make sure I have identified all those numbers. There's 2 5.4s. There's 1 5.0, 1 5.1, 1 5.3. What number am I missing? That's 5.0, 5.1, 3, 2 5.4s, 1 5.5. Don't see any lower numbers right now. I see, oh, I missed another 5.6. So there should be another 5.6 in here. That's why you have to double check your work. Make sure that you identify everything. So I have 1, 2, 3, 4, 5 here. This would be 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, 12. That's 13. That's 14, 15, and 16. So we have what our 2 middle numbers would be. 5.7 and a 5.8. Write that down correctly. There's only 2 numbers. That's why we're doing the division by 2. So we get 5.75. Our mode also does occur in that 5-point section because there's only 2 7s, 2 6s, 2 4s. There's 2 8s, but there's 3 5.9s. Even in the 6-point, there's 6.8 and 6.8. There's only 2 of them. So 5.9 would be our mode. Our range is taking that largest value, which is 7.0, and subtracting the smallest number, which is 4.5. So that should have been 4.5, correct? Yeah, 4.5. So that's 2.5. And can we identify any quick outliers in here? Let's see, we have 4 even on the low end, 4.9, 4.8, 7, 5. Those numbers are pretty close together. Is there anything outstanding or really out of the ordinary in the top end? Well, we have a 6.0, 6.1, 3, 6, 5, 6, 2 6.8s, and then a 7.0. Well, there's not a huge gap in between those numbers. We could probably identify that there's no outliers in that section in brand Y. So we're going to do a comparison. Let's see, our average for brand X is a little bit higher than brand Y. Medians are the exact same values because by chance, the numbers that were in the middle came up to be the exact same. Our mode for brand X is lower than the mode for brand Y. But our range is for sure a much higher number for brand X than brand Y. At the same time, there are some great outliers in brand X compared to brand Y. So if we were to compare these from letter B, which would you probably make as a choice to buy? Well, you could make an argument either way. If you chose X, you might get an outlier. You could be lucky. Well, ideally you would want the higher end. If you could have a battery that lasts 8.2 years, great. The lowest value for brand Y was a 4.5. But it would be very bad if you got a battery that only lasted with 3.1 years. If you wanted to go for brand Y, it's a much more consistent battery. Because even though the average is slightly lower, we're getting a higher average. At the same time, the range is smaller. Getting a 4.5 battery, not too bad, considering that the average is 5.72. So an extra 1.22 years, somewhat within expectations. At the same time, you could get a little bit higher. If you're getting the extension, that'd be about 1.28 years. So that would be good. At the same time, brand X, yeah, you could have something that lasts almost 2.5 years longer, or you could have something that lasts 2.5 years shorter. As a safe bet, brand Y would probably be your best choice. You could take the gamble, but it wouldn't be a very conscious or a very, very well thought out gamble. Now, suppose that one battery, including the set for brand Y, was defective, and its lifespan was only a half year instead of 5.9 years. So one of the 5.9s, they say that one only comes out as half a year instead. How would this or would not affect the measures of central tendency? How would or would not affect this decision on, how would it affect your decision on buying or not buying it? Well, what would happen? If we included a battery of 0.5 instead of one of the 5.9s, the mean would for sure lower. Our median, well, we'd actually have to go back to our data to see whether our median would be affected. Because we would be taking one of these values out, and it would actually go down here as a 0.5. Our median would actually slightly change. This would be our 15th number, and this would be our 16th number. The median would be 5.7, because halfway in between 5.7 and 5.7 is 5.7. Hopefully that makes sense. The mode also changes, because instead of having a mode of 5.9, one of those numbers, one of those 5.9s is now a 0.5. So we actually have multiple modes now. We'd have a 5.4 being a mode, a 5.6, a 5.7, a 5.8, 5.9 would still be one of our modes, but then we'd also have a 4.9, a 6.8, and a 6.0. We would get multiple modes. But overall, the question is, how would this affect our decision? Would it change our decision from going with brand Y? Overall, the decision probably, there we go, that's spelled right. It probably would not change. After 0.5 years, the battery would probably still be under warranty. And if it still has warranty, it could be replaced without any kind of charge or a minimal charge. One thing I do have to make another note that I forgot about. You can notice that each of our measures of central tendency, 5.74, 5.75, and 5.7, you can see that these values are very close to each other. Even on brand Y, 5.72, 5.75, and 5.9, they're still relatively close to each other. And all of these data values, somewhat are central numbers. Now you'll be able to go and have some fun.